All right. In chapter 2.3, section 2.3, we solve quadratic equations by factoring. And those quadratic equations either had a coefficient of 1 in front of the x squared, so we had to find factors that multiplied to make this number, that added to make that number, to factor it. Then we used the zero product property to solve. And if there's a coefficient not 1 in front of x squared, then we had to do the whole factor by grouping technique in order to factor it out, and then again use the zero product property to solve. Okay? Sometimes that factoring technique fails because it's not workable that way. Sometimes the answers are not rational answers. They're not like 1 and 2, but they're like 6 plus or minus the square root of 17 over 8. Those are the types of answers you get. And when that happens, we've got to come up with a new technique for solving to still get solutions, because this problem has answers. And we want to find those answers. But if I try to factor it in its current structure, this is positive 1x squared, which means I simply have to find two numbers that multiply to make positive 5 that also add to make positive 8. If we run down the list real quick, 1 times 5 makes 5, right? Is 1 plus 5 equal to 8? No. Any other way to make 1 times, or 5 by multiplying integers? No, right? So, the end, right? There's no way to do it the way we've done it because it doesn't factor. Okay, so we kind of hit a roadblock, so we got to come up with a new technique. And the technique we're going to use today is called completing the square. We have the basic completing the square, which is the one where there is no number in front of x squared. Then the more complicated one where there's a number in front of x squared, it's the same technique, you're just going to get fractions you have to deal with. And I know our displeasure of fractions comes into play there, but you'll get better at them by using them all the time. So that in mind, let's take a look at how we do completing the square. Step 1. We want that structure. So I'm going to write the steps over here as we go, and I want you to write them down too. You're more likely to remember them, and also, you know, having them written down in your notes so you can go back and look at them. All right. So step 1 of completing the square is you want ax squared plus bx plus c equals 0 order. I'm going to write down minimal number of words and or symbols, so you don't have to write down a whole bunch, but that's what you want your problem to look like, which is what we have right here, which is good to go. The second thing, if necessary, divide by a. Okay. If a is 1, don't do this step. Okay. Quick take a look at examples 3 and 4. 2x squared and 4x squared. So in examples 3 and 4, we're going to have to divide by those numbers. Okay. Reduce, if possible, any fraction that happens in that step. So I'm going to put in parentheses here, reduce. Reducing fractions is your best friend on these problems. It makes the numbers smaller. Once you've done that, step 3, we're going to move constant to the right. So as I do steps, I'm going to do them over here. All right, so first step is already complete. The way the problem was presented to me, it's in the right structure. Everything equals 0 in descending order, x squared followed by x followed by constant equals 0. That's what step 1 means. Step 2, divide by a is 1, done. Nothing to do in step 2 here. Again, that step 2 only matters if there's a number in front of x squared. Step 3, move the constant to the right. Remember, the constant is the number not containing x. So in this problem, I'm going to do x squared plus 8x, and I'm going to leave a gap equals negative 5. Okay, I don't say that over the words, but I'm going to leave a gap here. Because there's a magic number we're going to put in that little gap in a minute. That's going to be our step 4. So maybe I should put that here. Move constant to the right, leave gap. Everything I'm talking about on this process here, I'm going to tell you ways to maintain good organization in your work so that every problem looks the same and you have that systematic way of doing it. It makes the problems much easier to do. This whole technique takes about 35 to 40 seconds when you're good at it. It's going to take me 8 to 10 minutes to explain it, but once you're good at it, it's fast. It's just you do it, you do it, you do it, and then there's 6 steps, and when you're done with the 6th step, you get the answer. So, step 4, I'm going to do a different color because that's our important, super important, magical step. Step 4, you're going to add b over 2 squared to both sides. Okay, we've been working with quadratic equations now for a couple weeks, right? And a has always been the number in front of x squared, b has always been the number in front of x, and c has always been the constant, right? Every single time. Even in this structure here, you can see bx happening right there, right? So, when I say that we're supposed to take b over 2, this is what b is. B over 2 is a fancy way of saying half of b. What's half of 8?
4.
And what's 4 squared?
2.
4 squared? 16, right? So, it's not square root of 4, 4 squared, right? So, half of 8 is 4, 4 squared is 16, so I'm going to add 16 to both sides. So, plus 16 goes here, plus 16 goes here. I'm filling in the gap that I left with that magic number from step 4. I'm using the additive property of equality, which says if you have an equation, the blue stuff is an equation, right? If I add a number to one side, I'm required to add the same number to the other side. Okay, and again, this is the only number that will work, this one right here, which is exactly half of that number squared. That's always the magic number.
So you always do half of that every time?
Half of this every time and then square it. If it's a nice, pretty even number like 8, it's easy to do, right? If it's an odd number, it's a little bit more challenging. Look at example 2.
So it's not going to be...
If it's odd, it'll be harder. So again, when we get to a harder one, we'll take a look at it. But when it's even, half of an even is a whole number, and then you square it. So half of 8 is 4, 4 squared is 16. That's our magic number. All right, moving on to step 5. You're going to factor the left. You're going to add the right. The left-hand side is going to be a quadratic function, a special kind of quadratic function. There's going to be a very simple, easy way to factor it every single time. And the right-hand side is just a couple numbers, either add or subtract based on the signs. I use the word add in the algebraic sense of addition. If the signs match, you add. If the signs are opposite, you subtract. And you always put the answer to the bigger sign on it, right? So let's just do the add the right first. Negative 5 and positive 16, different sign numbers. I'm going to subtract the numbers. 16 is bigger, so it's positive. Right? If this was positive 5 and positive 16, now it's positive 21. If it's positive 5, negative 16, now it's negative 11. All right, so again, signs determine whether you add or subtract, and then the bigger sign determines the sign of the answer. Factor the left. Here I'm going to do it real quick, and I'll explain how I did it. Did I think very hard about that?
No.
What's 4 times 4?
16.
What's 4 plus 4?
8.
So x plus 4 is just x plus 4 squared. You're creating what's called a perfect square trinomial when you do this whole half of b squared thing. It's just you're creating a structure that's easy to factor. Now, the straightforward way of doing that instead of the backwards way, which is, hey, it's this structure we know how to factor, what times what makes this, what plus what makes that. The more straightforward way of factoring this, it always does this. The perfect squares, which is this one and this one, you take the square roots. And whatever this sign is goes in the middle. So the structure up here always factors the same way. The first object, take the square off of it. The second object, take the square root of it. And the third thing is a sign, which is whatever that is. If that said minus 8x, this would say minus 4. It says plus 8x, so it says plus 4. And it's always a parenthesis squared. So that factor left is always done that way. Say again?
Simple number like 8.
Say it one more time.
Will we get like so say it's like 7x, will we always get like a decimal?
That's example 2. We're going to have an odd number in example 2. I think all 4 examples cover all the bases of what could possibly happen in these problems. So this is the easiest possible example. Again, everything works out nicely. We have a nice even number here. It factors real nicely. There's no fraction showing up in your work. This is as easy as they get. Then I start throwing in the more complicated ones as we go. All right? So, everybody comfortable to this point with what we've done? So, next thing, you're going to have this structure every time. You're going to have a parentheses squared equals a number every single time. you're going to square root both sides. Plus or minus on right side. Did I say 6 steps? I meant 7. I usually don't throw that in as a step, that number 2. So, square rooting a perfect square gets rid of the square. So the effect of square rooting the left-hand side, I have a parentheses squared, is the squared goes away. So that the left-hand side, when I take the square root of it, I'm just taking the square root of this, squared, the square goes off, I'm left with that. So that side, the square root is simple, just write down what's inside the parentheses. The right-hand side, I'm going to put plus or minus the square root of whatever this number is, in this case it's 11. Sometimes that has an exact square root, sometimes it doesn't. If it does, fine, evaluate it. If it doesn't, leave it as is. If it breaks down, break it down. Okay, 11 is a prime number, it doesn't break down, right? If they ask you to approximate, use a calculator to get the square root of 11 decimal value and throw that in there to a couple decimal places. Right? But again, square rooting both sides gets this down to just a simple x plus 4, and gets this down to a simple plus or minus the square root of 11. So then our last step, step 7, is solve for x. Okay? Go back to Algebra 1. Back when life was easy and everything was not complicated. If you have x plus 4 equals some number, all you got to do to get 4 over there is chop it off and change the sign, right? That's all I'm going to do. But I do want to move it, I want to move it in front of the plus or minus. You always want the plus or minus something to be the very last thing in your expression. So when I move it over, it's positive 4. When I move it over, it's going to become negative 4, right? These numbers have different structures, so the subtraction and addition is not possible. I can't make this any prettier than what that is. This is the answer to the problem. And it's actually 2 answers. Okay, just to clarify the 2 answers you're looking at, one of the answers is negative 4 plus the square root of 11. The other answer is negative 4 minus the square root of 11. You don't have to separate them like that, but you can put the plus or minus form of it. Right? But that's what it means. Plus or minus means to both add and subtract the 2 numbers that you got. Okay. Guess what those 2 numbers multiply up to? If you do this times this on a calculator, guess what you're going to get? You're going to get that. And if you add them together, you're going to get that big. You know, that's just what happens, right? So, in fact, if you add them together, you get the opposite of that. But anyway, that's how you do it. So again, there's no way to find those 2 numbers just by guess and check. You can't make a table and come up with those 2 numbers. So this is the technique you're going to use, completing the square. It's very systematic and very easy to use. It's just a matter of getting used to the system. So you've got this written in your notes. This is your recipe to follow. Do what it says when it says to do it. The only tricky part, again, the factor of the left part is just that's how you do it. Square root, sign, put a square on the parentheses. Don't forget the plus or minus. A lot of people forget the plus or minus. If this evaluates or simplifies, evaluate or simplify it. But that's how you do it.
So should we have 2 answers?
Well, again, this is the same as this. This is where I go. I just wanted you to see there's 2 answers there. When you see x squared in a problem as the highest power, you're going to get 2 answers every time. So I just wanted you to realize there are 2 answers happening there. But I usually leave it as is. If you want to separate them like that, you're welcome to do that, but you don't have to.